we can see the
And the mouse is already.
Yeah.
It's a usual thing.
I'm going to get a mouse for this, you know. I hate this.
Ah, come on.
I agree.
Look at this, look at this. It's us, it's us.
I
It's
hate
us.
it with a
Hi guys.
vengeance. I don't just hate it, I hate it with a vengeance.
Yeah.
Oh, sorry, we're talking about the keyboard.
Yeah, now
Hey guys!
Hi!
Hey everybody!
trackpad keyboards.
Yeah,
Yeah. We're
we're hating, yeah.
Yeah.
How you doing, guys?
Oh yeah, all the people are all there, yeah. Well, there they are. Yeah, we are! Dutch.
Yeah, we're all here.
Hey, Paul, hey, Ray, hey, David, hey, Tony, hey, Digital Toys, yeah. All right, the band's getting together. We just saw that we have 741 subscribers on this channel.
Wow.
Yeah.
That is impressive.
This is
Well,
impressive.
considering
For we only doing the live stuff here, this is really,
and every
really
week.
nice, yeah.
Yeah.
So, thank you guys from our heart.
Yeah.
Yeah.
That's impressive. How many subscribers you got now, Dad?
1160 something.
Yeah.
No,
Yeah.
not bad.
Yeah.
Close?
830 or so.
Yeah, getting there. It's all heading in that way.
Yeah. It takes some time because I can't post regularly either.
I don't post regularly from principle.
Yeah, but I can't even if I want to. I have.
Hi,
videos
George.
recorded.
Sorry, excuse me. Hi, George.
Guten Abend. Ja, hey, Digital Toys. I didn't know. Ich wusste nicht, dass du Deutsch bist. Hey, man.
PM Crisp. Hi, Crisp.
Yeah, man.
Hi, guys.
It's the whole planet already out there. Hi, guys.
Yeah.
Nice to meet you.
Does PM Crisp eat crisps in the afternoon?
I think it's evening there. He says this.
Evening or yeah, then I was thinking like a PM crisp. Just
Yeah.
no.
Oh no.
I don't think that's what that stands for, but
Yeah.
Okay.
Yeah.
So we have something on the desk,
There was something on the desk. It's doing stuff. Yeah.
and not only that, it's in focus.
Yeah. Can you believe it? Yeah.
yeah,
This is me. Yeah.
we have a good camera finally.
Yeah.
We should put that one on the overhead.
No. I ordered some telescopic USB cables, so we don't have to mess around with the thing that.
Okay,
Yeah.
that worked as well.
Yeah.
Yeah, I'm quite disappointed on the Brio actually.
Well, it's a wide angle thing. Yeah.
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 So what's this thing?
This is just a new PDI adapter for the board.
Okay.
UPDI.
Yeah, it's a
one cable thingy.
Yeah, it's a one cable programmer. Yeah. If you watch the video on Richard's channel about the PCBWay package that we received, you know, the Christmas in February.
Yeah.
This was one of the projects, and this is a little display unit for the multi-load. Yeah.
So
And, you know, as these things go, you have to program them first because they don't do anything.
Yeah.
And,
Okay. No,
this is the current state of the. So I have a display. I have some numbers on there. This is raw value. This is not 725 volts. Don't worry.
Hopefully not.
No.
so it's not reading that. It's like just a random number.
No, it's reading the ADC, but the ADC. This is raw. This is ADC raw.
Because this is where we can.
It's not calibrated pretty much.
It's not changed to anything.
Yeah, you can calibrate the ADC later.
Yeah, we do.
And making it show the correct values,
Yeah.
but it is showing something stable.
Yeah.
Stable
The voltage looks good, and the A is open.
So if I touch this with my fingers.
do this, please. You saw that? Yeah.
Yeah.
The ADC goes up to a okay.
Yeah.
8,000 counts. Yeah.
Yeah.
This looks good. Yeah.
Yeah. So it's just sensing what's on the input.
Yeah, it should.
It's sensing
should do that,
something.
so.
There's something going on. Yeah.
Yeah.
This is a good sign. So for now, I'm pretty happy with that. But this is where today's episode starts.
Hi Gordon. Hi Mike.
We talked about the voltage regulator. What are they doing, the guys?
Freedom for tooting. Mike. Freedom for tooting.
At least I know what that is now.
Back to Wolfie Smith now.
Yeah.
Foxy.
All right. I don't catch his English jokes.
No,
It was an old situation.
He
probably.
explained it a few.
I'll give you an example. There's a group of them. So I think they decided to steal a tank from the army base, and one of them. So they went undercover. So Foxy's his mate's mother knitted up some balaclavas, so they just got the eyes, whatever. And she put the names on them.
Oh my god!
So it said Foxy and John and stuff like that.
Brilliant.
So they got arrested.
I haven't seen that.
Don't crash this. Let me get to back to the project here. So we were talking about we're having a voltage regulator on there, and we checked the data sheet, and it tells us about 25 to 30 volts. 25 would be great because USB PD, that is multi-load constructed for, goes only up to 20. So we're fine on this page. But we haven't tried this.
Yeah. So this is the voltage regulator on the input to this. So basically, for those of you guys who don't know, we don't know what the input voltage is going to be because it's a load. It's an active load, so the active load could be actually up to 30 was the original.
Yeah, 30 something.
Was specification, and 5 is probably the minimum.
Yeah.
So Detlef put a little voltage regulator on here, we can show it.
Show the people over there.
Yeah,
this is the same board, the back side of it.
That little baby there, that thing.
Yeah.
So
this can handle up to 25 volts from the data sheet, and I think absolute maximum ratings are 30 volts.
Yeah.
And we constructed this thing, and I measured this. It's about 10 milliamps. Pretty spot on 10 milliamps.
So this draws 10 milliamps.
Yeah, with the CPU active and the display active.
Yeah. So what we want to know is, if we use our bench power supply and we increase the input voltage to that.
Yeah.
So what's this? This is felt is just 2 LEDs.
This is a sacrificial board.
Okay. So what?
So we're absolutely prepared to kill this, and it has 2 LEDs on there. So to show us that the CPU is still doing something, because I didn't want to burn one of the OLEDs.
Ah.
Yeah.
Good idea.
So you've got a CPU on there doing something, and we're gonna stick into this up to 30 volts and see whether the regulator on the back can handle it or whether it blows up.
Yeah, I want to know how hot this gets, so we need a thermal camera.
Okay,
yeah. Now we have a theory, so we came up with the fact that if it's 30 volts input and the CPU is running on 3.3, the maximum voltage that the regulator drops is going to be 27.
So?
Yeah. And at 10 milliamps, if we take 27, well, at 1 amp it would be 27 watts.
Yeah.
That's the voltage drop. At 100 milliamps would be 2.7 watts. So at 10 milliamps, it should be 0.27 of a watt, about a quarter of a watt.
So that should be enough to
so
dissipate.
We think it should dissipate a quarter of a watt, but the data sheet's a little bit vague about this, and temperature rise and watts per degree and this sort of stuff.
Data sheets are a pain, when it comes to that.
Well, data sheets are fine with that. You remember, this is one of the new devices. This is not a 40-year-old design like a 7805. This can handle up to 85 degrees fine. It would be absolutely happy with that. So it's still interesting to see. We want to have we're probably going for a destructive test here.
Yeah.
Because we want to know what can we feed into that.
Where it does.
Yeah. Okay. Well, the power supply goes up to 32.
That's our upper limit.
Apparently the limit is 25, but it also says it'll go up to 30.
Yeah, I think this was the absolute maximum.
Absolute max was 30, and it's normal up to 25. But we're also interested to know that if the regulator dies on the back, what will happen? Will the regulator effectively go short, or will it feed the full input voltage through to the CPU, and the CPU will go
and kill the CPU and everything else?
And we don't know.
Digital toys. The problem with the Xena, of course we thought it was Xena with that. The problem with that is we have a wide range of voltages here, so we need to clamp to somewhere around 30 volts. And 30 volts is a lot of stuff for these little things. I think we do this way. We try this way and see what happens. This way we can tell the people, okay, you don't put much more than 30 volts in there.
Put that's a specification.
So these are the inputs, these 2 pins, So we connect the bench power supply to here.
Yeah. The middle one is ground. On the outside is the voltage pin.
Okay.
And I put some pins over here too, so we can connect a multimeter. To see the voltage that CPU gets.
Okay, so a multimeter on here. Do you know what we never thought with this multi-loaders? What if somebody connects the power supply to it backwards?
Then you have a problem.
You fry it in.
We could find that out as well.
You fry it in.
You want to fry multi-load? No.
I suppose actually we should have a high-rated Schottky diode and series of the input somewhere, so you can't.
Yeah, so if you put it backwards.
I would probably go for MOSFET. We have
a MOSFET.
We have way more current with that, and.
Okay.
Okay, that works as well.
Okay, so we want some wires, don't we?
We want some wires,
Yeah.
We want a multimeter.
Hey, my friend.
We want a multimeter. The wires are not needed because we have alligator clips here. They're already on the table.
So this will be destructive.
Ground.
It's for science.
Ground mid.
So this is the multimeter.
Yeah, I put the wire wires here.
If you wanna,
Oh, these are the wires from the power supply. So I'll
Yeah.
turn the power supply down to 0 at the moment.
thanks.
So we want one camera on this.
Yep.
We want to be able to see the multimeter. We want to be able to see the power supply.
Probably want to see the overhead.
Okay. So we want to see the power supply we're putting in. While Jet's setting this up, by the way, guys, at the car boot sale today, I found 3 retro computers. Detlef found another guitar,
Yeah.
which he says rocks.
Yeah,
And,
it's too loud.
I actually found a piece of test equipment and a box full of electronics. And Carlos doesn't know what it is. Oh.
I didn't go to the
Well,
flea market today, so yeah.
So
There's cameras.
I have from the flea market a box full of electronics. Oh, what's that?
Camera's dead.
Yeah, camera's dead again.
Which camera?
Wait,
real.
get the
Okay, one moment, guys.
It crashes.
overhead. This is the right one. Properties.
Just disable enable.
Deactivate.
Ready to then activate. Okay.
It's not coming back. No, it's not coming
Oh dear.
back. Alright, we go for. Sorry for the black
Yeah.
screen. We go for the handheld camera.
Yeah, side cam it is.
Side commentary.
Okay.
Sorry for that, guys.
No, let's.
This is getting to a point where the setup's so.
Crap.
I don't want to go for hard. Oh, crap.
He's right.
Gordon, this is test equipment, so.
Test equipment I bought at the test equipment at the car boot. So a little bit later we'll get this out and we'll have a look. And I paid good money for it.
Oh yeah. But why was there 15 volts?
Oh, I don't know.
Wait, what?
But then you want to go to volts.
You don't have any
excuse
volts
me,
on there.
Volts DC, and we want to turn the power supply on.
That's a good idea.
Yeah, no, but was it showing 15 volts?
What are you asking me?
It was showing AC 15 volts. Wait, what?
Look, AC.
Yeah,
That's a stray.
Yeah, this is
yeah, that 5 volts.
Yeah,
That's a lot for.
I've turned the
this
power
rate.
supply on now. But
Yeah.
It shouldn't be AC.
No, okay, there we go. DC.
Right, so the power supply is off, yeah?
Yeah.
So I'm going to
hit it with 5, please.
5.
take
It
it.
should be easy enough. The blink, the light, LEDs are blinking.
We have about 5.
Oh, LEDs are blinking.
Yeah.
This is good.
I'll do this.
Yeah, please.
And it's 0 volts.
That's a bit low.
What 0 volts? Why can it be 0 volts? The CPU is working.
That's a very good question, and I am touching both.
Try that.
There we go.
Wow, 3.300. You suddenly
That's-
see that.
That
That is precise.
That is precise.
That's really precise.
So we want to increase the voltage up now.
Yeah, please.
Yeah,
Hit me with 12 or something.
Hit me with your rhythm.
All right.
Hit me with 12 volts.
It's Gran Canaria, guys. You know.
3.301.
That
Okay.
was really accurate. Can we see how warm it's getting? It's on the other side of the board,
Yeah,
isn't it?
I'll bring out my phone. It's the easiest. from
Easiest
camera.
way, yeah. See how warm. We can use the finger test.
Oh, yeah. Please.
I already burnt my 3 fingers with your project.
Oh, I can feel it.
So, no thanks.
It's vaguely warm.
Vaguely warm. Okay, this is nice.
Whoever that was, I'm sorry. Right, it's vaguely warm.
Why can't I put
Because it's a live stream.
No, yeah,
It's always.
Why can't? So it's
about 45 degrees. So it's,
okay. So
That's
we
nice.
want some more voltage in.
yeah.
So you want to check the output again?
Go for broken, go for 24 directly.
Oh, you want me up to 20 foot?
Or 20. 20 is what the USB-C could provide.
Oh yeah, we're on 20 volts. That's what USB-C can give us.
Okay.
What's going that with?
It was
3.304. It's very
Rock
accurate.
solid.
It's
nice.
really nice.
Really rock. I can't say that. Rock
Come
solid.
on. All right. I'm pretty pleased with your selection there, my friend.
Okay.
Not
How
bad.
warm is it?
I'm working on it.
Does it pass the Carlos finger test?
My fingers already hurt. I'm not a good benchmark for now. I was welding with a torch, and yeah.
You shouldn't do that.
And
It's not
no,
healthy.
He should do it. He's fixing something for me.
yeah,
Yeah, indeed, yeah.
What's it reading?
45. So that
It's
is
still climbing.
that's
That's
fine.
45.
But it's barely warm.
Well, show. I'll up it a bit. So we're now going
So
up
yeah, 25 is the rated.
24.
Okay.
It's a little underrated. Okay, so it's climbing a bit.
Okay, what's the voltage coming up with now?
Let's see.
LED is still blinking, so CPU is still alive.
Yeah, so it hasn't gone over yet.
Yeah.
So I'm guessing it's
33.3, I guess.
3.305, maybe
3.3.
10.
Oh,
1.
10 million.
It's close.
331.
So you want to go up a bit more?
Sure.
Yeah, come on, this can be destructive.
Well,
20. It's over the rated limit.
no, the rated limit is up to 30 apparently, at absolute max.
Okay, so it's still there. The efficiency goes out the window when you're going this high.
I can't see the meter on the screen.
Nope.
It's still fairly accurate. That's with 28 volts coming in.
Yeah.
Okay.
You guys can see the blinking.
That's
lights.
29 volts coming in.
Ooh.
How hot is it now?
Yep.
Yeah, this is the interesting part.
Now it should get there. Yeah, exactly. So it should
No, it's staying still.
50 something. The hottest point. Hottest point you can see up there. There.
Oh yeah. Oh, good.
50 something.
51, 52.
So shall I put my power supply up to max?
Go for it.
The LEDs are still blinking.
Yep, I'm looking at them.
Can we look at the LEDs?
Mhm.
Okay.
Okay.
Right.
Still working.
Not blown
We're
up.
on max 31.5.
Okay. This
Still alive.
This should be
Still alive.
breakdown voltage for the semiconductors inside. 58,
That's fine.
58.
That's fine. The LED actually do about 13 milliamps, so we are 3 milliamps hotter than we do with the OLED.
Okay, so on the multi-load, I mean that's the maximum I get off the power
Let's
supply.
see how accurate
The power
it is.
supply is saying 10 milliamps sometimes.
It should be fairly accurate considering the CPU is still running.
Yeah.
Well, the CPU goes up to 5, I believe.
Yeah, the CPU would survive 5, but I think
3329.
if it
3329?
Yeah.
Hey, that's okay, so...
you know, I think if this would break in a spectacular way.
And how much is it warmed up by now? You know, he's had a bit of time now to get some warmth.
Yeah, so it's 59.
59 degrees.
That's fine.
So that's dropping.
So let's say you have an enclosure
Yeah, 10 degrees up to
and leave it on for a while.
Which is a load.
Yeah, pretty much 10 degrees more.
Yeah.
70 degrees with the
Yeah. But bear in mind the load is rated up to 30. We're sticking
About 10 degrees
31.5
more
in.
than it's showing now. So about,
Okay,
70.
so there we go.
And that should be fine for semiconductors that are
Yeah,
new.
sure.
So.
Yeah.
Okay, so if anybody wants to know a good voltage regulator to use in your projects, what is it, Dad?
Wait. As if I can remember things now.
Say get under the microscope.
AP7380 and the 3.3 volt version.
Can we get on the microscope?
There is a 5 volt version, right?
Yeah, you
On
can
the
get
same
a
one.
You can use a 5 volt too.
Oh, yeah. AP7380. And they came in all different voltages.
Yeah.
Yeah, I think I've seen the 5 volt ones on different mods console.
And remember, this is a SO. What is this? SO8905. So a very tiny thing. Do we have something compared?
Considering how much amperage does that thing handle?
This is an Arduino over there. So this is a normal chipset, and if you look at the little voltage supply,
so
this is one of those. So tiny.
It stopped working.
Oh yeah, because one of the leads fell off.
Oh.
But we can keep this running to see if it
Okay.
survives for a longer time.
Okay, so we can get back onto camera. We can.
Wow!
Wow! Oh, you missed it.
I missed it.
You
Try
fried
again.
it instantly.
I connected the power. It just fried.
It smells. Yeah.
I think it was the spike.
I can't believe we did that and missed it.
Crap.
The spike voltage.
Yeah.
The spike voltage.
It just died. So if you switch it on with
With 31 volts.
that's easy to see.
Putting on a beefy capacitor that takes a while to charge would fix that. right?
Well, you're probably right, but look at this. The chip just burned.
Oh, I'm sorry, guys. Jet didn't have the camera lined up. I didn't expect that to happen.
Yeah,
No,
nobody
because,
expected that.
because it survived 31
Yeah.
volts, but it can't handle the inrush.
Yeah. It's like the Spanish Inquisition. Nobody
Nobody
expected it.
expected. Right, let's measure the
Nobody
voltage across the
expected.
CPU now.
Oh yeah, let's see if it actually went short or open.
Well, you can't because there's no voltage applied.
You simply drop in the voltage on there.
What do you want me to do now?
Yep.
You put the voltage in. Which way round is it?
Yeah, it's right. The right way around.
It's so we can see if it's short open.
Well, it's drawing no power at all.
Let's see.
I saw a small spark though. So
Okay, so it's drawing 0 power from the power supply.
the CPU gets nothing.
yeah, so it fails open pretty much.
Yes, the CPU gets nothing.
So chances are the CPU is still alive.
The only way to find that would be fitting on the chip.
You can simply use. I can show you how we do that.
We can just run 3.3 volts directly into the CPU.
This is 5 volts over
Yeah.
here, and we have 5 volts over here. So you can simply connect the USB thing over here
Okay.
and feed it. Where it says 3.3, just go to 5.
Okay, we disconnecting the power supply.
Yep.
Yeah, please.
And turn it
This
on.
won't. This won't.
And
be
we'll
nice
turn it
for
on. Then we've got a power bank which has 5 volts.
So connect this to that.
Yep. I'll connect up the wires
So,
first.
okay. And we feed the phone.
No, you can't. You can't because I
Okay,
gave it pins.
Oh yeah, you gave it best. Yeah.
Sorry.
Can I ask you a
I
question?
didn't-
Why don't I put the?
I didn't imagine this scenario.
Yeah. No.
Why don't
it's
I
fine.
set the power supply to 5 volts? We just connect it to there. Why do we need this? Why don't we just connect
Because
the
the
bench
chip
power
is dead
supply?
over there.
There's nothing going in there. This is open circuit.
Yeah, the chip is fried on this side.
Yeah.
Board.
Yeah,
It
so-
won't go through.
No, but where are you connecting this power bank? Why
We're
don't you
connecting
connect
this
the
now
bench?
right to the CPU.
So why don't you connect the bench
Oh, yeah,
power
you
supply
mean
directly to the
here.
CPU? That's what I'm
This
saying.
is where the UPI power supply is in. It's set for it.
So no, he means doing this.
I mean, just take the bench power supply
you could do that too.
and set it to 5 volts.
You could do that too. Yeah.
That's what I'm saying.
that will work.
Yeah. Yeah. No, it's skipping the power bank. He was saying. Give me a
Well,
sec.
what would you want? It's on 3.
3.3.
It's on 3.3 now.
Yeah. Wait a sec. Okay.
I have 3.3 coming in now.
No.
No, you're
Oh, no.
no, you don't.
Dang cables.
Oh!
This is a goner.
Yeah, the CPU.
I don't know if you can see that, guys, but the CPU's died. One LED was on
Yeah,
Yeah.
the red one was
dim.
barely glimming there.
Yeah. So
Yeah.
as long as I didn't have it shorted from pin to pin.
Yeah,
I did actually.
I'm sorry, Dutch, you missed it.
No.
I can't believe it.
Wait,
Yeah.
it blinked.
Oh,
It
what?
did?
Yeah. Oh, that was hot.
Oh.
Where is it hot?
Oh, maybe the voltage regulator on the
It's
output
pulling
stage
it.
is killing the voltage now. But
Yeah.
we should see some current on the.
Oh,
Oh yeah.
it's
Look at the
getting-
current. Yeah.
It's drawing something. So if we remove
well, you can
this,
see it on the bench power supply if it's
Yeah.
drawing something.
if we remove this, we should be able to turn it on again.
Yeah. Okay. Now we want to know if the CPU has survived.
Yeah. Another soldering iron.
This is going to be my. This is becoming my go-to soldering iron on the desk.
Your daily driver.
Yeah.
Yeah, this is the TS101 which I reviewed. And it's turning out to be very useful.
Oh yeah, right. And
If anybody wants a little portable soldering iron, Jet would recommend the TS101, yeah?
Well, it's a soldering iron. It works.
yeah, that's the main point, right?
Yeah.
If it doesn't work, it's
Do
not.
you want some solder?
No, it's so small. I
Can
don't need
you
it.
get this off? Yeah, sure.
Yeah, I can. No issues.
He says.
Yeah.
Do you want some flux?
Maybe.
Well, Greg, I think this was very useful to know. Now we know don't switch it on with 30 volts on the input. I think this must be done for stuff like that. You need to know when your crap breaks.
At what limit?
Yeah.
Yeah.
It's only 300 degrees. Maybe you want to push it a
There
bit.
you go.
Yeah, pretty much.
Flux.
Plus.
Solder.
Yeah, I think it's simply plus.
Yeah, no.
While you're doing that, I'm going to unplug it and replug the Brio.
Yeah, I think this
That's it.
could be.
We'll see if that comes back on.
There was some thing going on there.
Okay, no, it's kind of going. No. Okay, let's go for the easy way. Flooding it.
Hammer.
We want to hold this.
Yeah. Not if. And no hammer if we want to try to test the CPU afterwards. Otherwise, yeah, it works.
Can you get us off?
Yeah, now I can. Was trying to do this stuff that happens when I try to solder stuff on. It flows around and
This is the live effect.
yeah. Of course, I soldered it to the freaking resistor or
The cap, yeah.
the cap.
You can get rid of the cap. This is not.
Yeah, it's not. It's just a power cap.
So this needs a warning label. Dutch, do not go over 30 volts. You
Cap
can do
level.
that.
Get off.
We've got it.
Yeah, and I took the cap off, but
That's
that's
fine.
fine. Yeah.
In fairness, it was 31.5 volts and 30 is
How
the
do you turn this
absolute
off?
maximum rating.
Just unplug it. Do the same.
That works.
I don't want to melt anything.
Put it on there for now, where you'll pick the roll until it.
Oh, that's metal.
Jim Chris, we can do this on the start screen. Dutch, not over 30 volts.
Okay,
I
so
was opting for some boobs on the start screen, but maybe we do the other thing. What?
boobs.
Boobs.
Okay, well, that's what he said. Yeah, I thought I heard wrong.
That's
Come on, you have the video with the.
You saw the video when we were on site. I will just mention to you guys, as the camera following the boobs, that was AI built into the gimbal.
Yeah.
It was nothing to do with us whatsoever.
Nobody touched that.
Nobody told me to do that.
No.
Okay, so let's see. Okay, we're filming right this time.
Yeah, go.
No,
No,
it's
CPU is
dead.
dead.
Yeah, it's right. As long as the cap didn't go short.
Hey, why is it drawing 490 milliamps?
Because
It's drawing off.
Wow, half an arm. Yeah, this CPU is gone.
Yeah.
The CPU is drawing half an amp.
Oh yeah.
Oh.
Yes, it is. It's completely fried. Okay, so the inrush jumped over the regulator and killed the CPU.
Yeah.
It did. Yeah.
So now we know the answer. It kills us. It jumps over and kills the CPU.
Yeah.
So if
Well, to be fair, we drove it way beyond specification.
so it's not the fault of the component. It's,
Yeah.
it's our own fault.
Nobody blames the component.
It wasn't
here.
our fault.
Well,
I mean, we were trying to prove how much it could handle.
yeah. So we did exactly what we were sent out to do. Actually, so,
exactly. So okay.
so it's fine.
So yeah, that was that one. We've blown something up. What should we do now? Shall we
Well, this was for science. Come on.
okay.
Yeah, and it showed that if you put in a really big inrush capacitor or maybe a transistor or something, you can save it.
Hey, I don't want to mess so much with the electrics on the because this is a metering device. So,
Yeah, exactly.
Yeah.
we don't have any different currents input source for the power. So putting a big cap on there.
Yeah,
maybe.
yeah. See, multi-load is
Yeah,
designed
but
to be a load. That's what it is. So it's
Yeah,
powered from the
but
device you're loading.
big cap, the only thing is you're going to introduce is a little delay, pretty much. Yeah, and no change in values. And the delay saves the...
If you really wanted, you could put a crowbar circuit with a Zener diode to trigger.
Yeah, but then...
So that if you go over say 24, it just blows the fuse. So we have a fuse coming in,
Oh, yeah.
and an SCR. You guys saw the crowbar circuit, yeah.
Don't they do that with...
What you do is you use an SCR
Oh, no, right.
thyristor, so that effectively
Yeah.
you have a Zener diode. So
upper
once you go above a certain voltage, it turns the SCR on, and that shorts out the
Yeah, they do
supply.
something similar
via
on
the
laptops,
fuse.
right?
I don't know about
TVS.
laptops,
Oh,
but
a TVS diode could
Yeah.
work.
similar sort of thing.
And with this way we have a
Yeah, but the TVS voltage, the TVS tends to explode or go short.
Yeah, that's just a
Whereas the
problem.
thyristor is just resettable, so when you switch the power off, it takes the.
Okay, better
Thyristor
choice. Yeah.
survives and you can reuse.
Yeah, so you have a Zener diode onto the gate.
Yeah.
But you still need a fuse, you need to...
Yeah. You have a fuse on the input.
Yeah.
So that when the
Arthur,
thyristor
hey,
goes short.
from Oklahoma. How do you say this? Try to say this, please. There's a guy from Oklahoma.
What?
Oklahoma.
Yeah. How do you say this?
Which?
I will butcher this. From
Stooges.
author thing there.
Indians.
No.
Taliki? Talik?
Yeah, no way.
Arthur.
Sorry, Germany here.
Arthur, how do you pronounce the place? How can you tell me how you pronounce it?
Telequa?
Telequa.
Telequa. Could be, yeah.
Telekai?
Yeah.
Telekay?
We're butchering it. I'm pretty sure.
That's my friend. Have a good one.
All I can think of where Arthur comes from is when they named the town, they've been playing Scrabble, and that was just the letters that were left over on the Scrabble
something
game.
like that,
I can't pronounce it online. Well, you can use phonetics. But yeah, no, I agree. It's a pain.
Oh, we have watchers from California here. Yeah, this must be the same weather that we have today.
Yeah, it's nice weather.
Yeah, California, I think would be nice.
Yeah.
I believe San Diego somewhere else, like that was. There's somewhere in California where they have what's called the Santa Ana wind, and I'm sure somebody else is going to tell me exactly where that is. It's San somewhere or other in California, and they have the Santa Ana wind, and that's the same as our Kalima. What we call Kalima,
okay.
They call it the Santa Ana wind.
Yeah, it's when the pretty much the
that's where
dust,
the code
dust
breakers. Oh, I remember that story. Yeah.
So, would you like to look at the test equipment I bought?
Oh yeah,
Oh
right.
yeah, come on. Yeah. This is
The test equipment I bought in the box full of
guys, you're in for a
electronics.
treat. You're in for a treat. Yeah.
A test equipment. Is it from the 1960s?
This is
This is older than
it's from somewhere.
Oh my god.
So this is
If it's older than that, I don't know what it is.
this is what you can find at a car boot sale.
If you're lucky, and if you don't buy a guitar.
Yeah, no. I bought video games last time.
Really?
Yeah, I found a Nintendo DS in pretty good nick. What the hell?
Okay, let us try if we can see this.
Can we get you over?
Okay, it's one of these.
Oh, but still doesn't want to work.
Okay, so then we do this.
Properties. Let me see. If
Let's just in case over activate. Over.
Oh, I got it. I got it.
We've got it.
It's back.
I
The
got
word
it,
is
I got
back.
it.
So this is what I bought at the car boot sale.
So it's Russian.
That was my first thought. It's Russian.
It feels Russian. It's solid.
It's from Chernobyl, we think.
Wait, let me.
It weighs a ton.
I think this says generator.
Can we?
This says generator. This says oscilloscope. And this says like binoc something or other. Well, that's an I. This is PITA. Can we?
Do you have the translator?
Oh, this is.
Yeah, what's going?
This ends with IR.
Yeah, I don't read Russian. I don't have that.
That's Russian.
Have you seen? It's not got any BNCs. It has like these two things here.
It's like banana plugs, aren't they?
Yeah. Does anybody know what this is?
Just give me a second.
You are probably right about the oscilloscope part, considering the buttons.
English. Camera.
XY mode oscilloscope.
Generator. I told you.
You're right.
Which
What's
are
this say?
Frequency.
Frequency rough.
Okay, and then you have the fine tuning thingy.
Frequency smooth.
Yeah, so I'm guessing that's the fine tuning.
So this gnocchi, whatever, pito.
Gnocchi.
Power.
Let's
Move
do
it
this.
over there.
Oh, this way.
Yeah.
Yeah, there we go.
It's power something.
Power supply.
Power unit.
Yeah, and then
Oh, so this is a
Oscillos-
power supply.
this is oscilloscope. Okay. Net. What the hell?
Look, you got V1 and V2 plus and minus.
Oh,
I'm.
Look, I can-
we probably
Yeah.
don't need to translate that.
So this is a built-in power supply with two voltage
Was
rails.
over there the other
Yeah,
oscilloscope?
let's go here. Oscilloscope.
So,
Yeah. Hey, that's really handy. The translator.
It is, isn't it?
Brightness.
You do realise, like, back in the 80s when we watched films like Blade Runner, this would be science fiction.
Oh yeah.
This was science
without
fiction.
a doubt.
Focus, offset.
Yes, it is. Isn't it?
Volts per division, so this is the oscilloscope.
Yeah.
Amplification, scan.
It's just a frequency.
Offset. Yeah.
This
Time.
is time.
X and
So
X
this-
and Y
right.
offset. So it is a XY.
So this is an oscilloscope.
Yeah.
This is a frequency generator, and this is a
Man, you
vent
didn't
power
know?
supply.
We do this all the time. Over here in Spain, I don't speak Spanish. And normally I have this on my phone and simply go through the supermarket. Oh, what's this one?
Yeah.
Yeah.
Don't laugh at me.
I do speak Spanish. So I never use that actually. Not that way.
This is why it's so hard to learn Spanish over here, because you have Google Translate and everybody speaks English.
Okay.
Synchronizer. So this is your trigger. Synchronizer.
Yeah. And so something internal, external, the
Internal or external. So this is an all-in-one electronics lab. Oscilloscope, signal generator,
And
and voltage dual power supply.
That's amazing.
I actually paid for. I had this and the box full of electronics.
So, considering the weight, it actually weighs less than your oscilloscope I borrowed.
Yeah. I don't know what happens if we plug this in or if everything will just go off.
Okay, guys, if we're suddenly offline, we're probably still alive. Maybe the fuse blows, but
Let's see.
it's 2020. Okay, so,
glass fuse. Let me just check that first.
So it's 220 volt.
Yeah.
this is a good start.
It
Okay, my fingers
it
hurt.
says something here as well.
My fingers hurt.
I think this is who made it.
Yeah, it is. It's-
Kombinatorische Blabla-Werke in
Can you
Ostsibirien.
get that off?
No.
My fingers hurt, so I can't really.
Combined.
Binary
device for ham radio.
Yeah, okay, that would be useful.
It's got some big naff-off transistors in the back of it. I can see them from here.
Okay, we can check the fuse. Oh, it's is it a push-down twist thingy? Yes, it is.
Yeah, it's push and twist.
Okay.
So how's the fuse look?
It looks whole. Yeah, it's fine.
Yeah.
The fuse is good.
It's rusty inside.
It
But
has a fuse.
yeah, so we won't burn down the office at least.
No.
Well, where I'm sitting right now, if this thing blows, I'm pretty screwed.
Can you get the fuse back in? You have
Yeah.
to push and twist.
Yeah, no, I'm looking for the catch. It has a
And it's a
small-
1 amp fuse. And it's 220 volts.
Okay, so it has a catch. It has to go into.
That's the thing with life. It always has a catch.
Yeah, it does.
Yeah.
And it usually sucks. Come on, get in there.
Carlos is broke it already.
Yeah, I usually break stuff. I broke my fingers before I came here.
Let me see if I can
Yeah. Burn mark, burn mark,
get.
burn mark.
Right.
You try to work again, right?
Yeah, Richard's stuff this time. It wasn't my own.
It won't go down.
Yeah, it won't stay down.
Right, you already killed us, okay.
Did I?
Maybe we're lucky and this won't work anyway.
There's no way this won't work. Wait.
Yeah, this was Russian, yeah.
So it seems to be a combined.
Oh, there we go.
It basically seems to be a combined electronics lab.
Yeah,
With an oscilloscope, a dual power supply, and a signal generator.
I would say portable, but more of luggable.
Pluggable.
Yeah.
Okay.
We should have.
We should put it in.
Yeah. Okay. So let's.
Let's get it on the above camera. That's the best one.
Yeah. Okay. Okay. So this is a metal can. I don't want to touch this while it's on.
Oh, yeah, there's no,
Would you like to
there's no earth.
measure the resistance
Yeah.
across
No,
here?
because there wasn't any.
Would you like to measure the resistance across there?
Yeah. Please.
At least.
Quality.
You measure that.
Paul suggests you use a variac to power it up slow.
I have one, but not on this bench.
Yeah, on the other bench we can't record that. So
I can't record
for
it.
science we we won't.
For science, yes.
Okay.
Pretty science.
So no shorts on the voltage input at least. So that's good. But
Okay.
that doesn't have a ground, so shielding can actually kill us if we,
Why did they put shielding on that one? I don't get that.
you mean the ground wire?
Well, maybe this is a Russian design and they didn't need shielding.
They don't have ground.
How about if we connect the current limiter?
Oh yeah, that would
Oh,
that would
that's
work.
a great idea.
Unfortunately, this bulb is gone. Jack knocked it on the floor. Yeah, ages ago, but I didn't like to tell you. But this is a.
That's the external bulb. Okay, fine.
So next time we find somewhere bulbs, we need to buy some.
Incandescent
The
bulbs
trouble
are
is that
getting,
this one's like an English socket.
yeah.
Oh.
Incandescent bulbs are getting harder and harder to find.
He also broke the socket, so I just need to replace that.
Okay.
So yeah,
Okay, so
we
let's.
want to power these.
Yep. Oh, he did this. Oh, yeah. As long as it works.
I'm just a bit scared. Just a bit, a tiny bit.
Yeah, I know. I'm going to be handling it, so it's
There's a
fine.
little switch on here which you set it to limit or live. So that's a limit.
Yeah, so I want the limit at the start at least.
You'd expect it's going to draw some power, so the lamp will probably come on.
Yeah. Yeah, no, this is old electronics. It should draw some voltage.
So it might
just to
draw
turn
too
on.
much. Is there an on-off switch on it?
I couldn't see one.
This thing?
Net probably, yeah.
Yeah, net. Yeah, okay, yeah. So leave it out. Usually plugged in is.
Okay.
Yeah, okay.
Right,
I'm not
right.
touching the
Go!
can.
Plugged in.
No bang.
Okay, we're still there, and people are not screaming at us.
Okay, I don't want to touch the metal can.
Oh! I hit the click.
Yeah, nothing on. So it's not coming on.
Okay.
It has nothing
Is there another on-off switch somewhere?
on the back maybe.
It's not live.
Okay, I don't. No, and the light hasn't.
Didn't light up at all.
No on-off switch on the back.
Okay, so that requires a bit of investigation, guys. More than what we can do on the live stream.
Let's put it on to live, just in case if
Just go for it.
Yeah.
Go for broke.
Switch the switch on.
nothing.
Nothing.
No, okay, so no, and just make it safe. Let's unplug it.
I feel so much safer.
Who's interested in seeing a tear down and possible repair of this one?
Huh? Why was this so sloppy?
It's a bit shit, isn't it?
Oh, yes, this could be. Go directly into the socket.
Okay, okay, Rich.
So
We're going to disappear from there,
Yeah.
fortunately.
It
But
was nice seeing you guys.
okay, 3, 2, 1.
Okay.
Holy crap! That felt crap.
Okay.
it's on!
It's on,
Really?
and it's beeping, and it's humming.
Oh, there's something charging.
Yeah. Kaboom! It can actually boom.
And that is obvious. We already did that. Carlos checked the resistance between on the connector.
Yeah. I did, that's the first thing I did. Okay, can we turn on the oscilloscope part? No. That's a fluorescent tube, so that could be that.
Not fluorescent, it's a CRT.
No, CRT. I mean, the usual used for vectors.
Is there any voltage coming out of these outputs on the power supply?
That's-
Oh, I can hand you an oscilloscope.
No, we don't need an oscilloscope.
That was a function generator.
Is there any voltage coming out of this thing?
Yeah, I'm going to check. So I'll put it on the side here.
Yeah, Carlos fixed it by putting it into the right.
Absolutely, we need a
It's-
tear down and figure out what's wrong with it. This is what we're here for, explanation and discussion. Yeah, we're not going to tear this down on the live stream though, guys. It's something I'll happily do on
8 volts.
Right, let me just twiddle these.
8.5.
Yeah.
9. Yep. It is. The voltage supply is working. Yeah.
Oh, look, 14. Yeah.
So that's working.
Nice.
We need something to check the frequency.
That's why I was
out.
handing you an oscilloscope.
Yep.
Yeah.
Perfect. Good job.
No, use the multimeter. Just go to the hertz range.
Oh yeah, you could do that.
Yeah. That is true.
And then this will be ground. This is square or sine.
Let's go for sine wave. That should be good enough.
Yes, we have some kilohertz.
3.6.
1.1.
1.1.
Yeah. So it does basically function at least.
Yeah, and this is the smooth setting.
Yeah. So the function, so that's working.
So it's only the
Only the
oscilloscope.
oscilloscope that doesn't seem to work.
Maybe this needs some time.
I think it needs, no.
The screen is probably broken. It's actually probably working.
I don't think if the CRT is broken, you can tell they go like all blackened on here once you lose the vacuum. So I don't believe the CRT is broke.
Maybe the driving circuit behind it.
That is the main. That's what people are saying. So we can do some exploration right now and then work up a future video. Okay, so let's have a look see what's inside it. Yeah.
Yep, that we can do.
Okay.
Okay, so let's unhook it.
Let's unhook it.
That beeping it makes me a little anxious.
It makes a beeping noise.
Don't you hear it?
No.
Really?
It has
This
a
was
very high pitched
16
hum.
kilohertz.
No, I can't hear it.
Yeah.
Oh, if it's making a high frequency noise, that is the line oscillator for the.
Yeah.
Yeah,
And that's what it's doing.
I think we should keep it running for a bit. Maybe the.
It needs to heat up. Yeah.
Yeah.
No, the heat will heat up much quicker than that.
Yeah.
Okay, let's have a quick look. Yeah, guys, so they say he was making a high frequency
Let's
whistling
disconnect.
noise.
Did you disconnect this switch so I don't kill myself?
Okay, let me
Yeah.
just suss this out.
Just in case. I don't want to kill myself online at least. So this should have some voltage inside now. We should have to.
We'll leave it on one side for a bit,
Yeah.
and let's look at the box of electronics that came with it.
Yeah. Yeah.
Yeah.
But this is cool.
So this came with a box of electronics. Right. Now,
Whoa, that's so heavy. Quality electronics. At least I can say that won't break over time like the cheap stuff we buy. Today.
one box of electronics.
Yo. the case is worth of mention.
Now, I will say, guys, I actually paid good money for this.
Yeah.
The guy would not take less than €50 for the box of electronics and that. And I thought, you know what, for €50, I'm going to have
50 is
fun of it.
fine. The...
How do you get into it?
No, I know how I get into it. I just looking if there are markings. This doesn't look like your normal, typical box.
Of electronics.
Yeah.
Think it was worth €50?
Yeah, it was. The scope itself was worth a lot more.
Yeah.
Okay, so...
Just because it's vintage. Right, here's the box of electronics.
Oh, crap. Yeah, this is for ham radio.
Right
stuff.
from China, Bull.
This is for ham radio stuff, yeah. Oh my god. This is a repair box for ham radios.
You think so?
Something
Yes,
like this.
it is. It has all the spare parts as well.
Look,
Oh my god. This is well worth over that.
this is worth over the €50 I
Oh,
paid for the
yeah.
whole lot.
Yeah. One of those will cover it. Good.
Let's do some valve porn.
Yeah.
OTK24. These are strange numbers on these.
Probably Russian again.
Can we see
Yeah.
any more? Oh, yeah, we have some numbers here.
Yeah.
It's all in Russian. 6A.
Yeah. Let's take
So
one.
you swarm
Oh.
intelligence out there, tell us what this is. Of
This,
course, it's a valve.
this is a 5 something 40. It's 5 and then a funny little symbol, then 40. If you see it.
Socket. Okay.
Yeah, can you see it now? 5. I have it vertical. So
Oh my
there. 5 something 40. Can you see it now?
Yeah.
This guy, this guy repairs stuff. I'm guessing some kind of repair for old radios.
I think what they call this, this stuff is called silent key. A silent key is basically like an amateur radio operator who's no longer with us.
Yeah.
Okay, look at this.
Okay, so this is a self-built test device, right? Yeah, it is. Yeah, on a piece of cardboard, more or less.
Beautiful.
It's
Or wood wannabe.
hardboard.
Yeah,
Yeah.
wood wannabes.
Little bulbs, little.
Okay, so bulbs. So this is not. Yeah, it is for testing. So it's bolted down.
Spares for Apollo 9.
Oh, yeah, totally.
You're not wrong. They used these kinds of components for that.
Yeah, well.
Lon says,
One
what a
dog.
fantastic find. Those tubes could be really incredible, valuable.
Yeah.
Always at possibility they look brand new.
Yeah. It's they do it brand new.
Yeah, and there are boxed ones.
No, this is not PCB, Paul. And I can appreciate the historic value, but for me, this is.
Oh, that looks like it's burned
Okay, yeah. So
or used. Oh, look at this thing. What?
that
What's that?
that looks like a tube, but
Looks like a tube, almost like a fuse, because it's only has 2 connections.
no, but it has some. What?
It has 2 connections.
Yeah. So
Is this a rectifier?
that is really
you
cool.
guys out there, if anybody knows what this is, please
Yeah,
let
I
us
don't
know.
have a clue.
Gordon Bond, you've hit the jackpot.
Yeah, I think you did.
That is a. I can only assume that is a rectifier diode. It has 2 eggs on. It's a vacuum tube.
Yeah. So yeah,
It has some funny Russian.
and it does have a connector here that can actually melt. So that's like a fuse.
I think, guys, I mean, we're having a preview of this now, but I think on LER this needs a
Yeah.
video. This needs some
Yes, it
good
does.
topic so people can get involved and try to work
Even
out
the
what,
resistors are
what some of this
amazing.
stuff
Look at
actually
this.
is.
Look at the assortment of resistors and capacitors here.
Well, again, me is not. I know the historic value, of
Yeah,
course,
yeah.
but it's a resistor.
Yeah,
What the
yeah,
fuck?
Yeah, no, they're a lot better today than
Yeah.
they were left.
And I have no use for valves in my project,
No,
and I think valves
Oh,
are.
these are packed in so
Another
tight.
yeah, he did a good job packing in stuff.
that it's
What's
not-
in the blue things over here?
There are the connectors in one of them. Let's see what this one has. So
You mean
Another-
the DigiKey one, Roy?
another tube. Okay, so he has a small baggies with stuff. Okay, let's see.
Okay. I can cut away if you find some drugs in here.
Yeah. It's actually legal here for if it's not heavy stuff. So
Yeah, you never know.
if it's heavy stuff, fuses.
Well, to be quite honest, I mean, like bags of fuses.
Yeah,
Yeah, it's only fuses. So.
yeah, and they are whole. So these are new old stock. I'm pretty sure you can sell the entire box for about 500, 600 euros.
I don't know.
I am pretty sure you
This
can.
says OTK 79 on. Can somebody Google that out there, one of you guys? OTK 79. This thing.
Pre-transistor, yeah. This is way pre-transistor.
Yeah. So these are all fuses on the first box. Different ratings. Still fuses. The normal glass fuses.
Yeah.
Just want to get everything back where I took it from. These were connectors. I checked this before. Sorry for the bad angle. So these are. Looks like to be the tube holders for the board themselves.
Oh, valve holders.
Yeah. The vacuum tubes.
Oh.
There we go.
Oh, and like the little metal.
Yeah.
Well,
the
yeah,
cans.
yeah. These are basically shielding for the valve for high frequency radio frequency.
Yeah.
The little can goes over the top.
So it has a small assortment of connectors. This one goes over like this. Okay. And you hook it in. It's just like the car thingies you can buy. So that is fine.
Here's another one, so we can quickly Google that. So VIII, like a Roman
66.
8-66. But there's nothing much inside. Well, there's nothing in this. Just a filament.
Yep.
Can you see it?
Yeah, it's hanging there.
It has 4 pins on, but
So it has some. One of the pins go up to something else, right? No, they don't.
looks like a filament lamp of some sort.
Yeah. Okay, let me put this back. I don't want to lose you stuff.
Valve porn.
Yeah.
Yes, it is.
So
Vintage valve form.
yeah, that's what makes it valuable. Not that it is valves with stuff, because you can get newer-ish valves from different vendors nowadays.
How old is this?
This is from 1950s at least.
I'd say 50s, yeah.
Yeah. Wire,
Oh, yeah. This I can use.
wire, and some knobs, I guess.
Okay, I'm done after the wire.
These look decent enough, I guess. So I'm pretty sure you can get a collector for old ham radio repair stuff,
You'll be interested in
and they
this.
will pay through the nose for this.
Okay, we have one more we can look at.
Maybe this is a thing to set up a...
Oh, it's another OTK. This is OTK1.
Okay, it says in numbers on the
Mhm.
resistors what values they are.
Yeah, 22, 51. Okay.
Oh, interesting.
Yeah,
Sorry.
it's
Was just
pre-standard. What's
Uh,
this? Okay, so let's see what he packed in here. Drugs. No.
At last. Come on. Show us something interesting.
Bulbs.
the thing is, when you know about with drugs. I mean, weed here, you can just grow it on your balcony
Yeah, you can.
or on
Yeah,
your windowsill. You just
And no, and it's legal.
yeah.
As long as you don't sell it, it's legal.
These have survived. This is the interesting part. It's glass and
Yeah.
they still look like wood.
Yep. No, they look okay. I see the filament is connected.
Maybe the vacuum is gone, but
I doubt it. No, if the vacuum goes, they get like a funny colour inside, don't they?
Yeah. They usually oxidize quite a bit, but looking at the shielding, I think this is the original color, but it is kind of faded.
He even took all the
Yeah, no, he did a good job packing, that's for sure. I wouldn't have that. Oh, there's another baggie. Whoop.
Whoa.
So this is something you can show to someone that's 20-ish years old and doesn't have a clue what it is.
Yeah.
Oh, right, yeah.
Because the vacuum tubes are not a thing anymore.
Yeah.
Oh, the
Digital choices. OTK1 Röhren, the tubes, $10 each.
$10 each, yeah.
OTK1 tubes $10 each.
$10 each.
Yeah, each, yeah.
Okay.
You
Well,
have quite a few.
yeah, I've got a few. We had OTK 66 as well, was it? Oh no, VII. It's like a Roman 8, VIII, which is 8 in Roman digits, and then dashed 66.
So he was a holder. These are just screws. Screws and washers and stuff.
Okay, we saw screws before.
Yeah.
Okay.
So he's a hoarder. Yeah. Of course, if you worked in Russia repairing radios, you should save every
Oh,
part.
yeah, this could be a different thing, yeah?
Yeah, because it was hard to come by. So maybe. What? So why did he save these?
Isolated. This is an
Yeah.
isolated for...
Yes, but okay, you saved 2 of them.
Go ahead.
Yeah, like I said, depends on where you were when you were repairing this stuff, because you can't get everything at hand easily, especially pre-Cold War. So yeah, no, not bad.
So I wasn't ripped off for €50.
No, not at all.
No.
Yeah, I think you made like 500 or so.
Yeah. Russian Volvo together. Yep, guys, I was not. Oh, OTK 79 is a Pento, $27 on eBay. So I was definitely not ripped off for €50.
Yeah. No, not at all.
Including the oscilloscope test one. Okay?
Yeah, it was the oscilloscope included in the video.
Yeah. The whole deal was the two together. Was
Yeah,
was
no,
50.
These look like caps. Look at the little sign over there.
Yeah, those aren't.
That
Those
looks like
The
a cap.
caps 0.022 microfarads.
Yeah.
But they look like high voltage insulators on the tops.
Yeah.
They must be capacitors.
Are they high voltage?
Guys, what are we looking at now? What are these things?
High volt capacitors.
I'll go back to these.
What are we looking at? Well, they mark like capacitors, 0.022.
These are inductors, right?
No, they're resistors.
I guess
These are high voltage resistors.
Yeah.
They are.
Yes.
These
I
are
haven't seen them.
variables because they
No,
can
they're not
set it-
variables. That's just a mounting thing that you can bolt
You
onto
sure?
the chassis.
It looks like you could
No.
move this.
No.
I see what you're saying, but
Yeah,
no.
it's not non-conductive.
These are variable
It's
resistors.
ceramic encased resistors.
But these capacitors, they must be capacitors.
Is this a foil capacitor? The one that they just spun around foil? There is some text here. Borrow me your phone.
Oh,
I don't think I have
Yeah,
a
London. Is that some kind of threaded capacitor? That's my opinion. It's some kind of threaded capacitor. And I've never ever seen the likes of that in my life.
I'm upside down, right? Yeah. Sorry, guys. I'm just trying to film. Yeah, film capacitor. Yeah, I was
what's the
right.
rain?
Yay! I was right. KBPR. KBPR. Oh, okay. Yes. Okay, the text there. So that's the brand.
0.022 microphones, I think that is.
Yeah. So you are right, but why that?
220 volt.
Okay.
Yeah.
Oh, 500 volt DC, 220 volt AC.
Mm.
These are threaded capacitors I've never ever seen.
Yeah. And if
Why not check? Okay, yeah, right. Yeah, Mike.
I see.
I'll get the capacitance meter. Check the caps on the meter.
Yeah, good idea. that would be a good idea. Let's see if it gets something.
No, I don't think.
No, it won't. Actually,
Oh, HE, yeah, it does. It says.
it has an issue with a lot of the same text though. But hey, that's useful.
It is. It absolutely is.
Capacitor.
Let's see. So,
Well,
these are not polarized, right?
they're not polarized.
No.
$40.
47, yeah?
This is marked to 47.
Yeah.
What is
0.
threaded ones?
0.047.
0.022. Oh,
So
don't know.
this one is out, probably. And this one?
No, they're really about 0.7.
Yeah, but remembering, what was it? Our old teacher of electronics at school.
They all be the same.
Yeah, he told me about something that some caps only work at the rated voltage.
Voltage,
Yeah.
possible.
So they show something different until you pass through voltage.
They measure between the threaded portion and the other end.
Oh yeah, good idea. Okay, let's get a good contact.
Ah!
Oh.
Oh!
Good catch.
One dog!
0.047. Yep, that's correct. And this one is 0.02.
Just thinking of the history of this stuff. Yeah, the history is as if he could talk, yeah, 0.47. 0.047, they're reading now.
Yeah, and let's see, this is
0.022.
22 again.
Yeah, exactly.
Spot on.
Spot on.
This one is a little out, I guess, but yeah, 0.19 is 0.2 as well.
Okay, well, close.
Yeah, it's close.
Oh yeah,
enough.
this is Russian for it.
Russian fans, yeah.
Yeah, 20% something or other, 10%. Yeah, that's probably the tolerance.
So, guys, that's my piece of history I found. These are trimmers for altering like potentiometers, trimmer potentiometers, or trimmer capacitors, or trimmer inductors.
Okay,
and they have a long handle.
This is the first thing I think is usable in here.
Heavy duty.
Yeah. This is not a cheap Chinese crowd.
So beefy. This won't break on you, that's for sure. Let's see. Give a sec. Knife.
Rory, feed through capacitors, he says.
Yeah. Screwdriver.
Soviet, not Russian. Oh yeah.
Oh yeah.
From the
Sorry.
age. Yeah. Sorry. Yeah, you're right.
Yeah.
True. It wasn't Russia yet.
It was Russia, but Russia was.
Yeah. It was.
It was all the rest of the places after the war. It became the Soviet, USSR,
USSR, Soviet Union.
Union of Soviet Republic. You know, I should know that.
I don't.
Union of Soviet Socialist Republics.
Yeah.
USSR.
So let's put in the knife. Put in the tweezers are liked very much.
Yeah. I can see this. I can see the. I'll do a video this week. We'll have
Yeah,
a good,
this has some value.
This has some value.
Yeah.
And so shall we quick tear down on the oscilloscope?
Yep, it should have discharged something. Yeah, no, even boxes. Yeah.
Of course, it's like once you open it, you can't get it back in.
Yeah, I know. That's cool. If we turn this,
It's just this, is just paper.
Yeah. There we go. Yeah, this won't go down any further. So.
Yeah, it closes.
Yeah.
It's in.
No, wait. The metal left is not over. There.
It's in. Yeah, it closes.
There we go.
Okay, we have it.
Very heavy.
Does this say something?
Probably. But this is.
Where's the phone? Does that say something?
I don't think that you can reach.
No, this is cursive wannabe.
Okay.
So it won't decipher that, I think.
Okay.
It's not that good.
Ugh. No, not yet. Just give it a year or two.
Indeed. Yeah.
Yeah.
Okay. So, if you guys want to see what's inside it, we can get rid of that.
This is insanely heavy though. Okay, so let's see. Screw holes on the back. No, this is just for the feet.
I'm sure it won't.
On the bottom. Yeah.
Those are just the feet, aren't they?
No, there.
Oh.
There. So
I'll try to get in touch with you over that.
and one here. Okay.
Yeah. Try getting trapped with you.
Sorry.
This is a flat blade.
Yeah, flat blade. Oh yeah.
I try to get some focus on here.
Yeah. So it has some kind of. Is this finger tightening? Okay, yeah, it does.
Is this a screw?
Yeah.
No, she's here. It's terminal.
Yeah, so it's separated from the actual connector. Cool. So it has a nerve. It's just.
It has a ground.
Oh, nice one.
One of the screws come encased in one of these hand.
Yeah, like a thumb screw.
Thumb screws, yeah.
But not a thumb screw.
No, and it's come loose from the epoxy inside.
Okay.
So it's practically unusable.
The oscilloscope might need some of those parts. Yeah, it may do. It may do.
Yeah, considering the age of this, yeah.
Yeah. Well, we'll have a quick look, and then again, I'll make a proper tear down to see what we have a quick. Let's have a quick look inside.
Washer, screw. Okay.
Is this loose now?
No, you need to take out these as well.
Okay. Oh, then the whole cover comes off.
Yeah.
Right.
Disassembling video games that have complex parts usually helps with noticing stupid design ideas. These are very straightforward to get in.
While Carlos is doing this, does anybody know when crosshead screws were invented? I mean, I remember seeing adverts on the telly in the early 70s for Posi-Drive.
Phillips.
And Phillips. I'd never ever seen a crosshead screw before them. Was that when they were invented, or just when they started to advertise DIY?
I think Phillips popularized it, but
Mike, they were feed-through caps, much smaller versions used on UHF transmitters. Okay.
Yeah, you are 100% right.
Probably. Oh, UHF modulators inputs.
Okay, so this should come off now, right?
I don't know.
Let's see how it's put together. So it's split in the middle somewhere.
So do the feet hold it together?
Yeah, this one's...
This is like spring loaded or something. That's on the middle bit.
Yeah, and it should...
Well, it says this is...
Can I just pull out the electronics? No, it can't because they lip.
Do you have to take the feet off as well?
I'm guessing...
Maybe?
We're just trying to figure out how to get in it, guys.
Yeah. Sorry for the bad angle, guys, but I need to see what I'm doing. Ow! Okay, that was sharp as fuck.
It's off. Don't worry, it's off.
Okay, so this is split in the middle.
Is this with the oh!
Yeah.
Oh crap!
Oh, good luck with this one, Rich. I give up already.
Yeah. What's nice knowing you?
Oh
You
my
are
God. It's multi-leveled. Oh, Jesus. Look at this. Oof.
Oh man.
Oh, holy crap. And look at the switch relay. Wow.
Yeah.
Okay, now I think even you are going to have a struggle with this one.
I think, you know, this... I will make a video about...
Let me do some money shots here.
Do you know what? I think this needs to go to somebody who's a specialist in this or who wants this.
Yeah, you can show it off on stream, of course, and make people aware of it.
These wafer switches.
Look at the bus bars.
Are these buzz bars?
Yeah, they transfer power from one board to another. Look.
Right.
Oh
wow.
My God. And yeah, they have the bus bars that go to...
So we should be able to get the other top, get a top off of the mate and look on the other side.
Yeah.
You want to make a topless?
Ah, there we go.
We want to go topless.
There.
No. Let me do the video here first.
Yeah. Oh.
Oh, is it nice? See?
Yeah, there's a chip.
There's a chip.
84. So it's not as old as I thought. 1984.
You're joking.
Look at this.
That can't be.
0584.
Was that a date code, really? Yeah, but I mean, chips didn't come out really until the 70s. So this is not Valve. This is...
0484.
Yeah.
Wow.
How? But why is it built so crappily?
It's Russian design, man.
Soviet.
Soviet design, sorry.
Wow.
Holy shit.
These are transistors in here, I take it, under these little metal things here.
Yeah, they are.
They are.
Base, emitter, collector, no doubt.
Yeah.
So this is no... Yeah, well, I honestly thought this was like really old.
Considering how it looks, yeah, and the build quality. So no, this is just built to specs from 1960s.
Is that a whiteboard?
It is.
It's some Nixie thing.
Yeah. But why? Inside?
Look at these funny 20 microfarad electrolytic capacitors.
Like these.
Yeah.
Is this a date code? No.
Oh, this also says OTK on this. So are they a manufacturer who also made this?
Maybe.
Because OTK was the thing we saw on those valves.
Yeah. Okay, so there's a screw there, a screw there, screw here, and screw here to take off the top.
Top. Okay.
Okay.
Let's get the top off.
Let's make it topless.
Can anybody believe this is from the 1980s?
No, I don't. But there is an IC on, so maybe.
Yeah.
They maybe built it the
Mike,
same.
that will all fit on one chip. Exactly what I'm saying, yeah.
Nowadays, yeah.
Do you want some tweezers so that doesn't fall down the side?
Yes, please.
Okay.
There we go.
Oh, you got it.
I got one of them, but the risk that I drop one of them is quite high.
84. When did the wall collapse? 85, right?
Yeah.
The Berlin Wall, early 90s. 91.
Yeah, so
No, now I have to Google this crap.
That I can tell you now, the Scorpions had the song Wind of Change in the charts before the Berlin Wall fell, just by chance. And it then went to #1 in the UK.
Yeah.
Just by
can
chance.
reach from here. So I have to be careful with the caps on this thing because they will be charged.
They may have some charge in them. I'm still fast. I honestly thought this was much older.
Yeah.
November 89. So this is
okay.
five years before Soviet Union collapses.
Okay, yeah, they didn't have they didn't have access to new parts. Okay, yeah.
Yeah. Dave, thank you.
That should be in line then, yeah.
So when was Reunification Day?
For what?
Reunification Day,
Oh, the thing in Germany.
otherwise known as the day that West Germany bought East Germany for far too much money.
November the 3rd, I
believe.
think. Yeah.
Is that correct?
It must be 89. Yeah.
Yeah, I don't know history about Germany.
No.
Yeah, just
It was a German guy who told me that. He said,
just the normal things, Hitler and stuff, but
you put Hitler and stuff in the same sentence as normal.
Yeah. That's why I said
it's what the rest of the world thinks about Germany. Sorry.
Shit.
It's true. Just being honest.
Are we getting there?
Yeah, we are there.
So we didn't find any valves in this. This is all transistors and solid state.
Yes, it looks like no, but I see valve connectors.
No, there's
No,
valves
the
in there.
caps. These are the caps.
Those are the caps.
The screw-in caps. Oh look, we actually found some that are being used. The screw-in caps.
So we move this to the front like this.
Yeah.
Click it back in so it locks. Tip
this
it
side.
over.
Yep.
And then the top comes off.
We hope.
Hopefully.
And it does. Oh.
Hey, what? Wires. Oh, there we go.
Okay.
Wow. I like that. the tube display. Not bad. I wasn't expecting a built-in.
Well, you expect it's a CRT.
Yeah.
Oh, they make electric screwdrivers now. Fine.
Okay, good. They're still around. That's impressive. Wow.
Wow.
There's some caps buried in there. Some heavy resistors, I guess, on these heat sinks.
Yep. Yeah, these are
Caps.
transistors, yeah.
These are massive heat sinks in the back there.
Yeah. Look at all these switchable capacitors. This is the function generator
Yeah.
Oh yeah,
for
yeah.
all the different frequency ranges.
Wow.
Look at all these loads of switchable.
Okay, this is cool. And the transformer is just one beefy.
Just a one beefy transformer. So this is your power supply section.
And yeah, from the different taps.
Yeah.
It takes out.
So those metal things under there, those are your smoothing caps on the output of the power
and
supply.
there are the massive caps.
But they'll be low voltage because this is.
Dave, I'm German and I don't know this fact. Thank you for looking. Thank you. You're better than with that than me.
What?
He's telling the German history there.
Yeah,
Was it German Republic?
yeah, like I said, I only know the part that they forced us to learn in school.
Uh-huh.
It was unfortunately only.
What's the tolerance on those caps, Paul? I think
5%.
it doesn't matter
It
anymore.
says these 5%. It says on them. I've seen it somewhere.
10%.
10%. This one says 5% over
Yeah.
there.
Yeah.
Probably what they had at the time.
Yeah. This one is full of caps. I can see inside.
Oh, there's a load of caps under here.
Yeah, inside the can. That's probably the input. Side.
So these big power supplies, these will be your regulator transistors on your on this.
Yeah.
On your variable power supply.
Yeah. Jesus.
It's like a bit of electronic social history. This.
Yeah.
You know what?
I like those.
I like my little chips that can do
I
this
like
all in
those
one
too.
chip and cost $2.
Those I haven't seen those.
These are sexy.
I haven't seen those before.
Well,
These.
sexy isn't the word that comes to mind with.
Well, it's cylindrical and long.
Well, they're slim and naked. What more do you want?
Oops. Have to remember Lily's over there.
Oh, sorry.
Yeah, no, she doesn't.
Crystals, right? I'm missing crystals over here. There's a frequency
Oh.
generator. There's no crystals.
Yeah, you're right.
You're right.
No, it's Paul that said that.
No, but he's right.
This is the board that drives the CRT.
Yeah, I'm looking at the
that's what we see
neck
at your
board.
controller.
Yeah.
So where's the HT connection going to the anode on the CRT? So normally there's a connection up here, like on the TV
Yeah,
CRT.
exactly. In underneath, I guess. Yeah, I think so.
The high voltage.
Let's see. No, it doesn't have a high.
It doesn't
voltage.
have a high voltage connector on the tube.
So it goes through the
base.
the neck board. Yeah.
Wow.
This is cool.
I love this camera.
Yeah.
Yeah, no, I use that for my overhead camera, the one they are using right now, because it has a really nice depth of field.
Yeah, look at this.
Yeah.
Yeah.
And the zoom in function is really good.
So it sounded we
That's
had a,
why I wanted to change that one with one of those.
Oh, come on, I use this way more and probably will be totally disappointed if I faff around with that one.
well, if it was making the high frequency whistling, which you say it is, that's a problem with the line output stage, which generates the high voltage for the CRT.
Yeah.
But,
So
but there isn't a line output stage. I'm thinking of TVs.
yeah, no, it probably does have it, but through one of these wires that go through the entire thing.
Yeah.
So normally you want it close to the screen on the top.
The
because-
HT, the final anode is up here. Yeah.
You want it. You don't want it close to anything else because it can short out.
Yeah.
So, but looking around at this thing, I don't think.
I think those CRTs are still available. I saw Mr. Colson's channel, he did some kind of repair and commented that the CRT might be available or was available. Yeah, I think somebody like Mr. Colson would be really interested in all this stuff.
Yeah. 100%.
Absolutely.
And considering it 90% works, it's just
Yeah.
the CRT.
I don't think the CRT is faulty itself. If a CRT fails, you can see like a blackened on
Yeah,
inside.
no, it could be one of the stages to
Yeah.
start it up.
Yeah, so I think so. There's going to be an oscillator, high frequency, which generates the HT.
Yeah,
And I think that's what you can hear
but
whistling.
I'm still looking for the crystal. I can't see.
There are no crystals.
Yeah, but for making a for you need a
No, this will just be resistors and capacitors.
Really? All right.
Well, first of all, it's a low frequency signal. It's not, we saw
Yeah,
some
yeah. Gotcha.
Yeah, okay.
hundreds of hertz.
Yeah, you
and
don't
stuff
need
coming
a
out.
crystal, really. Yeah, no, okay, you're right.
If it had a model number, it does have a model number. Oh, and it says on the back 1984.
That's what I said.
So this is George Orwell's.
Yeah, this is George. Yeah.
This is George Orwell's test gear.
So,
I want myself one.
cool, okay.
Okay.
Time to put it together.
Put it together and then we'll look at something else.
Yeah. I usually.
I think this is a spaghetti field of designers repair. Yeah.
No, I'm totally with you.
Yeah, no,
Yeah. This is something I wouldn't touch with a 10-foot pole.
I'm with you there. I like challenges. This is impossible for me.
Yeah.
There is no challenge because there is no use.
Yeah, no.
I shut
no,
up.
no,
I shut up now because I'm the
Odd one out.
obviously the punk here.
Yeah, no, and you're not a collector kind either.
No collective gene
Are
anyway.
you on the right way around or the wrong way around?
It's the right way. It just needs to.
If I would
slide.
find this in my basement, I probably threw it in the trash.
Yeah,
Oh, sacrilege!
Yeah, it's
but
totally. I know.
people would cry.
People would try that, yeah.
Yeah, no. Look, I wouldn't buy this either.
I did buy it.
Yeah, but
And the box full of
I-
files, and I still think
I
I've got a
collect-
bargain.
I collect stuff, so I know the value.
Yeah.
This can the entire kit with the repairer kit and
Yeah.
everything. You could probably get 500-600
Do you
euros.
think? I'll
But
I'd like to make a bit of a profit from it, but I'd be quite happy to see this go to somebody
Of course, a fella.
yeah, of course.
who appreciates
God,
it.
that fucking
Oh, he's dropped the screw. Well, the cover comes back off. So.
yeah.
Where did it go?
Where did it go?
And I found the washer.
There it is.
There it is.
You found it.
Yeah. Okay. So. got sliding this.
Yeah, because you got, like I say, you got all the spaghetti, all these wires. I mean, if you try to take this board off to get to the solder side of it, how many of these connections are going to fracture and whatever? This takes a certain skill to work on.
Yeah,
This
no.
is soldered, right? There's no plug-in plugs.
No,
No, there are no plugs.
No, they're plugs, it's all soldered
Can you show
together.
this to the people? This is even more horrible than I thought.
Yeah, so all
Yes.
these wires are soldered on.
Agreed
I
completely.
didn't realize that. Oh my god.
Yeah, no, this is horrible to work
Yeah. Right to repair on a different level.
on. Yeah. Right to not
Yeah.
repair.
Louis Rossman, look at this. Right to repair.
Yeah.
Absolutely bonkered by unrepairability.
Yeah, and you think that's just a modern.
Yeah, no, but this wasn't intentional, I'm guessing.
No.
It's not like Apple that they screw
I guess.
over there.
I guess if you bought this in '84, you probably get the schematics with it.
Can I ask you guys, while Carl's putting this together, so this is an
Yeah.
interesting question for all you guys watching, yeah? Yeah, I agree, it's a time capsule in the electronics antique. I completely agree, Warwick. It wants saving. It wants saving.
Warwick,
Yeah.
I understand the train of thought there, but for me, this has no practical use, and everything that doesn't have a practical use, no fucking way. I won't keep
Yeah,
that.
so
So,
there's
I will give it to Richard.
The
because I know
collector-
I know that he uses
yeah,
this stuff.
the collector gene.
Yeah.
He doesn't have it at all. So.
Yeah.
this definitely doesn't want scrapping, this wants saving. It really does. I
So,
agree.
but-
oh, yeah, but
You need.
You're doing good. You're doing good.
No. Okay. Go
okay,
ahead.
yeah. So the question I'm going to ask you guys, and Det can also think about this as
Oh
well,
crap! Me again.
and because Det was telling me about PCB practice of PCB layout and design, and how you don't have tracks that go through like right angle turns.
Oh yeah. Oh yeah.
Because the electrons gets dizzy.
Yeah. So what? So if it's bad practice to design a PCB with right angle turns, you have like 45-degree angles. Why do the vias through the board go through vertically? Why don't they go through at a 45-degree angle? Because every via is a 90-degree turn.
I can explain that for you. It's
Oh, yeah,
too
what's-
hard to manufacture. Otherwise, they would.
Yeah.
So, yeah, but you see boards with all the fancy tracks going around all the curves
Yeah.
and whatever, and then you go through a via which is a 90-degree
Yeah.
turn. So, hey guys, what do you think? Why does it not matter that the vias have 90-degree?
Well,
They do.
actually, I can skip into that.
Yeah.
There was Robert Fennick did a video about exactly this topic about should we do 45 degrees, should we do 90 degrees, is 90 degree bad? The normal train of thought is if you have a 90-degree angle, it creates a antenna thing because it's a very sharp angle.
Yeah.
And
Actually,
yeah, Robert tried this out with high frequencies, and there was no
there's no way.
different.
This is like there was a TV program in the
So,
UK.
Keeping your 45 degrees angle is more a aesthetic thing.
Yeah. Actually, they were recommending to do the old style, the wavy lines,
Wavy lines
instead.
Yeah. Wavy lines is the best.
And
thing you can do.
that was the hand-drawn
Yeah.
style, and that was what was recommended actually to use.
So this reminds me then of like in the UK and everywhere else actually. So when you go to a petrol station to fill your car, the sign saying "Do not use your mobile phone."
Yeah.
So a TV program.
Mythbusters.
It was either Mythbusters or Brainiacs. But was it probably the one is. So they had this on the TV in the UK where they took a caravan and they didn't like caravans much on this program. They took a caravan and they filled it with like petrol cans all with the lids open.
That's Brainiac.
And was it Brainiac? And they put like about 150 mobile phones in there.
Yeah, Brainiac.
And they texted them all at once and nothing happened.
traps.
So then they did the same thing and they actually phoned them all at once and nothing blew up. So then they blew up the caravan.
The
Anyway.
embedded hobbyist just gave us a reason why 90 degrees is bad. Acid traps.
Oh yeah.
When you etch these PCB,
Okay, yeah. For
when you have a 90 degrees angle, you
manufacturing.
can trap the acid in the corner there.
Right.
Manufacturing.
Oh,
Yeah, this is the first time I hear a good explanation for that. Thank you very much for
So
this.
when you say acid traps, you mean the etching solution?
Yeah, it
Yeah.
gets stuck there. Yeah.
I think that's has to tuck inside that at the back. First.
Yeah, but it has to tuck inside on the front as well.
Yeah. Okay, that's in now.
Okay. And
Yeah.
that's one.
Okay. So yeah.
Yeah, and then it has to tuck inside. Of
Yeah.
the
Well,
front.
no. So why are we so scared of it exactly?
So
Does it introduce more risks of engineering fractures occurring?
it depends on what you're building. If you're doing PCB, PCI Express Gen 5 or stuff.
Yeah.
It's very important to have the correct EMI.
And all the tracks have to be the same length and all the rest.
Yeah, exactly.
Yeah, but the wires are still vertically through the board.
Yeah.
Even when you get to the BJ at the end, it has to go vertically through the board.
Yeah, so there is.
And that's a 90 degree.
Yeah, it's a 90 degree. Oh, crap. So.
Carlos can't get us back together, but
Yeah, it's the shielding. It's kind of wedged in there, but it's wedged in from both sides at the same time. So.
Well, this is going to go on a video short, which I wouldn't worry too much.
Yeah.
As long as you don't lose the screws.
Yeah, that's pretty much what I was trying to do, to put it together.
Yeah.
So you can close it at least with the screws.
Now you're saying
Okay.
try to understand the era. Of course, this is nice from a historic point of view. From a practical point of view, doesn't help me. Doesn't help me at all because all this technique in there is obsolete. I can do the function generator with a $2 module controlled by an Arduino, so
Probably better.
Okay.
it's probably better than this thing does.
So
and,
I had the same discussion with that regarding emulators. For video games.
oh yeah, this is one of our favorites.
Ah, you've got it.
Yeah.
This is always one of our favorites.
Yeah. So emulators are frowned upon by purists of video games. I'm not one of them. I enjoy emulators. They do it a lot easier to get good quality output from TVs and stuff.
Yeah.
Because if you hook up an old Nintendo to a TV, it looks like crap.
Influenced by Tektronix.
So it uses, especially something like the Mister, that is a perfect emulator. Yeah, but I do like collecting my stuff. So I do like fixing the old things.
Okay. Can I answer some questions?
Yeah, sure.
So, Wandor, yeah, I agree with you. This looks like a Tektronix piece of equipment, like the colour of the metal.
Yeah.
Yeah, because I actually have a Tektronix 458B 100 mega oscilloscope here.
Maybe this is.
And yes, I get where you're coming from.
A clone.
Kind of, yeah, it looks that way. And Mike, yeah, motherboards with very wavy PCB tracks. This is because if you have like a data bus, for example, where you
Length
have...
of the tracks is a spot, length of the track.
Yeah. But say a data bus where you're sending like data to PCI slot. All the data has to arrive at the same time. So therefore, the frequencies they use, the tracks have to be the same length.
Yeah.
And that's why you have wavy tracks. So each track actually is the same length.
Yeah.
So that, yeah. So all the bits that make up the bus, the data bits, arrive at the same time.
Okay, Rich, it's not on this side.
So we're coming apart again.
Yeah, so save the screws.
Oh dear. I'll find a bag.
I give up on this. It's the metal shielding. It has to wedge in from both sides. So you have to bend it, and I don't want to bend this.
I see there's a recurring theme now. Carl takes stuff apart. Carlos, but
Yeah, I'm good at taking stuff
it
apart.
doesn't go back together quite so
You
well.
never said that you were good at putting things back together.
No.
If there is a screw over or something, it's fine. That's usually the philosophy for cars, at least.
Iron, you could use it for holding up the door. Yeah, this would be my choice of use of it. Yeah, as a door stopper.
A door
Or
stop.
pretty heavy paperweight. I don't have so much paper.
I think this should be. I think these things should be in a museum.
Oh,
Oh,
don't
okay.
start a museum here.
No.
Well, we could.
Well, what's the two's coming?
We could rent the shop over there.
Yeah.
The aircon shop,
Yeah.
is it empty now?
Yeah, then you have to sign on it.
Yeah. We need to stick this back on the end of sellotape. Anybody?
I know where it is, but I can't get out of it.
Okay.
Ah, crap, my fingers.
You know what? That's been so interesting. I haven't done that. Anybody want to be here?
Oh no, I stick with.
Carlos, I have something for you.
Oh yeah, we got presents.
Oh, thanks.
These were gifts from the guy who sold me these 2 boxes of electronics for 50 euros.
Looks like a fruity drink.
It's not alcoholic, unfortunately, but
Yeah, it looks like one of those.
it does, doesn't it? Yeah. So, yeah.
Looks tasty. Orange.
Really? At the stock exchange, they have the same length of
How
cables in there?
They do the same at the stock exchange, having all.
Well,
I
know this goes in the millisecond range there. Yeah.
Yeah, because it's the difference between going bankrupt and rich. sometimes. So yeah, that's a good idea. Okay, Rich, it's done. Here we go. Oh god.
You make a beautiful video with that.
Yeah, I'm pretty sure.
Yeah,
you
we're
will.
all going to watch this and okay, door stopper.
Yeah.
Sorry for me being the
No,
the
but
rude one here.
I don't have any use for it either. I got my new scope. It's 100 times that, at least.
I remember, yeah, this is.
I haven't done a video yet on the scope because time doesn't permit it. But
Remember me saying if you want to do this,
yeah, collab. Yeah.
yeah, let's just land it to us and we'll give a.
Yeah, let's do a collab.
Yeah, yeah, but because the scope is actually decent. I've been testing around just a bit off camera,
Okay.
and it's really fun to use.
Nice.
But yeah, the annoying part is the menu things.
I just saw one of the new regulator
Regulator.
they run on Android.
Really?
Yeah, and they have a big screen. But you know, I don't need a scope for €1,000. I don't do enough to really use a €1,000 scope. I was tempted because it probably has a protocol on it.
Oh, crap.
Yeah, we're late.
David T, does anyone know why some electronic devices call for alkaline batteries only?
Nice. What? I missed that. Sorry.
David T, does anyone happen to know why some electronic devices call for alkaline batteries only?
Oh, probably the
that-
voltage regulator and the set for that voltage.
Alkaline. What was it? It's the amount of power they can deliver, pretty much at once.
Oh,
you mean
so
The C value.
the internal resistance
Yeah.
of the battery. Because people that I know this. People don't always realise it. So basically, we all know that the electronic circuit is a circuit.
Yeah.
So you have a wire from the positive going through the switch to the bulb and back to the negative.
Yeah.
But the circuit isn't complete. The circuit also goes through the battery.
Yeah. So it has to go through the battery.
Has to go through the battery. So all the current that's flowing through the circuit is also flowing through the battery.
Yeah, and the resistance there.
And the resistance of the battery
Affects.
matters, especially if something's taking like bursts of power.
Yeah.
Also, when a battery goes flat, it doesn't actually go flat. The battery is still generating the correct voltage, but the internal resistance goes so high
That it stops.
that
the
it stops
flow,
supplying current.
the flow of
Yeah,
electricity.
yeah. This is why you can take your multimeter on like a flat battery, like a CMOS, it'll read 2.9 or 3, which is effectively the correct rating.
And that's why batteries revive in if you put them in the fridge.
Well, there you go. Yeah. So,
They revive for an hour or so.
Yeah, so,
again, what they heat up.
Mike Penchot says smoke alarms say alkaline only.
It's because the internal resistance goes down when the temperature goes lower.
Yeah, and also
It looks like it's alive.
yeah, and your multimeter has such a high load resistance when you measure the battery. That's why it doesn't.
Yeah, it doesn't
read.
show anything.
Yeah. Smoke alarms say alkaline only. That's probably because alkaline batteries don't explode during the fire that's causing the smoke.
True. that can be one of the cases.
Maybe.
But yeah. And alkalines usually have more power per, let's say, weight.
The power to weight ratio.
Yeah, so they have more milliamp hours inside. Of course, LiPo would be better, but in a fire alarm, they explode quite nicely in fires. So maybe not a good idea. I've seen fire alarms with the diamond battery, the radioactive ones.
Okay.
Yeah, they never run out, pretty much. 3,000 years. So that should be enough.
Chances are there's a fire in this.
Yeah. Smoke alarm as a wife. Yeah, your life depends on it. Is this because something to do with like with the alkaline battery when it effectively goes flat? Does it kind of do it suddenly rather than tailing off, so you get less and less of voltage? So effectively, when you press a test button, you know it's gone.
Yeah, but it still needs to beep when it is getting low and annoy the hell out of you.
So I think the actual answer is then to David T's question: does anyone happen to know why some
The C
devices
rating probably.
call for alkaline batteries? The answer is no.
No, not for sure.
That's the question. Does anybody know?
Not for sure.
Not
but
for sure.
But usually the alkaline batteries are used for RC cars because of the amperage drop. So you don't use rechargeable batteries for
No,
RC cars.
you use lipos for that for RC.
Now
Same
that
with the drones.
now that lipos exist.
Okay,
Yeah.
I mean, back in
Yeah,
the days.
older RC cars that had the wire plugged into the controller. The old kind that, or the Skeletrix ones that could kill you. You had the 50 volts running through the track.
Really?
Yeah.
Did that cause the cars to like jump off the track or something?
Yeah, and if you touched both of the tracks at the same time, you got the nasty shock.
Shock?
Yeah. Yeah, the new versions have a 24 volt.
No, they were 12 volts when I was
Yeah,
young, so-
12 and 24 are the normal safe ones, but they started out at 50.
Really, the ones when I was young was 12
Yeah.
volts.
12 and 24 are the safe kind.
Yeah.
If you put something metal across that, you can still burn it out if you saw the transformer.
So yeah, I mean, thanks for the explanation, but I lost several pieces of chest. Oh, somebody says it might be due to alkaline batteries don't leak.
That's true.
So therefore they won't, when they fail, cause the equipment to... This is David T. I've lost several pieces of test equipment. No, due to leaking alkaline batteries.
Well, I say, alkalines leak all the time.
But wait, alkaline.
Somebody said that my age. So if you have...
Any MH batteries leak.
That's nickel metal hydride or
Yeah,
something?
the rechargeables.
Yeah.
You have to stack them up. So
Don't know.
It's hard to say, actually. Good idea, though. And yeah, you're right. Alkalines do actually leak.
There are a lot of very strange, inexplicable things in life. I mean, not electronics related, but I bet nobody knows. I bet you've all seen this. You go to the petrol station to put car or diesel in your car, and on the petrol pump it says minimum delivery 2 litres.
Yeah.
Why?
Yeah, they want to charge you at least for 2 liters.
No, and what happens if it... There's a reason why.
Yeah, it's because the pumping ratio. It can't pump less than that.
You're close. So the reason is that according to weights and measures laws, if you sell a liquid in a quantity of say 50 millilitres, the amount has to be accurate within a certain tolerance.
Oh yeah.
But as the amount increases over a litre and over 2 litres, the tolerance increases. So it actually means that they can actually either make the pumping machines cheaper because they don't have to be as accurate, or they can make them extremely accurate and rip you off for 1.5% of everything you're putting in your car.
Yeah. So those pumps are really accurate. Actually.
But this is what we're talking about the other day when we thought, okay, let's measure how much difference is in the...
And what?
We were talking.
Oh, we were talking about it the other day. Yeah, let's go fill some up at these petrol pumps and see whether they actually are within the tolerance, or whether they always give us at the bottom end of the tolerance, because the tolerance is plus or minus. So you could make the petrol pumps very accurate, so they always give you the minimum legal amount, so you can do it, and they make a few extra pence per litre.
Petrol pumps don't work like normal pumps. They use a metering system that lets through.
Dave says it. The accuracy spec is only good above a liter.
Yeah. That's right. That's correct. That's what it says.
Yeah, that's good.
So if you put less than 2 litres in, they will still charge you for it.
Yeah, they charge you for the 2 liters.
David, as one as uses rechargeables everywhere, I use rechargeables everywhere. Maybe not in a smoke alarm. Smoke alarms are a different beast, and I would go for alkalines there. But normally I have rechargeables everywhere.
Yeah, no, I agree.
I go for the Eneloops. Yeah, they're expensive, but they work and they don't discharge.
I heard something else.
No, they really work.
No. I heard something else when you say the Eneloops. Eneloops. Okay.
Whatever. Yeah. You know what I mean. Yeah.
Eneloop is something else.
Okay. So
I don't know.
No. Just put the words together. Anal lube. I heard that first. What? Excuse me?
is this a family show?
No, it's
Not anymore.
Not anymore.
It wasn't to begin with. Let's be honest.
So we have 20 minutes left, guys. What else can we play with?
We can ask, see if they have some ideas for next time.
Please let us know. Ask us anything. Yeah.
Yeah, it's for next time. Do you want us to rip apart something fun?
Oh, damn.
No, don't explode.
Don't ask us to put anything together.
We can put something together, maybe a kit or something. Maybe I can force these guys to do a video game mod.
Oh no.
I have a mod kit for the Nintendo GameCube ready to go.
Okay, what game should I play? This is the only thing I can do.
Yeah, no, after you
And
mod
then
it,
remember, I'm old.
after you mod it, you can play the GameCube, and I have 100 games so far.
Detlef found this at the car boot sale. He's trying to work out how it works. So
I know what it is, but
we don't know how it works at the moment. But yeah, that's what something else that Detlef found at the car boot sale. If anybody's got any ideas about that.
This is a strange thing, you know. This feels old.
Yeah.
It doesn't feel like plastic.
I didn't
when
know
we,
that was
when we were down at the university, we played around with some graphene. But this can't be graphene, right?
no, not in that quantity. I would be super expensive.
Cute.
Well, we got to one.
Oh,
Yeah, that's interesting. Hardwired smoke alarms are required.
due to people taking the batteries out and not replacing them.
Yeah, because they beep and annoy the living shit out of you. Yeah, okay. I get it.
They need a battery, or they were annoyed by the bleeping thing. Yeah. That's the usual stuff. Yeah.
Yeah, but are they mandatory though?
They're probably not.
Smoke alarms.
Probably on your house insurance.
Yeah, if you get insurance, probably you have an
But-
inspector.
Am I right in saying that, like in California and the USA, houses are built from like wood, rather than like our houses are built from like
Stone.
inflammable stuff like stone and bricks?
Yeah, and shittily built.
Yeah, but they don't burn.
Yeah, they don't burn.
They don't burn.
They don't burn, but they shit quality. That's for sure.
Yeah. Building regulations and Canary Islands
They don't exist.
have a bit of almost related.
There are no building.
A bit like drone rules, and if you want.
If you
don't get me
see
started.
Bob the Builder build a house, he does it a lot better.
I never knew you were Bob the Builder, fan.
Yeah, I was.
Gordon, you mean the 2.4 Arduino IDE? I saw that it came out, but until this is a thing with the portables, I'm not going there.
Oh,
Yeah, for me, there's no real reason to switch. Maybe intelligence. I know intelligence, but
Yeah, so
I'm old. But
I'm using the older Arduino IDE as well because it conflicts. The new one conflicts with some of my libraries I use.
Welcome to library now.
Yeah, so no, I won't switch until they fix the libraries.
Yeah, they never switched up. They never do because
No, I rewrote one of them just to make it work, and then another library broke that depends
Of
on
course
the
it
new
is.
one. So
and you can compartmentalize with the old one.
yeah,
You simply use for this project. You use one installation, and you use a different installation for the other one.
so
Way easier.
yeah, you are right.
has anyone? This is David T. Has anyone ever used an inductor tester for a transformer? In what way, David?
Gordon, wait for my friend.
Inductor test of photon. Yeah, okay. So a transformer is practically an inductor. So yeah, sure, it should work.
But what do you mean by measure the inductance of the transformer, or do you mean to test for shortage? I mean, in what way do you want to test the transformer, David T?
Okay, so if a transformer is fine, it should have some inductance. Otherwise, it won't transfer power.
Yeah.
But if it's shorted, it should have no inductance. Right.
Yeah.
That's probably the idea. My guess.
No, it has inductance whether it's shorted or not, and I've tried this.
Okay, it depends on which turn of the wire it's shorted. Then you need to know the inductance beforehand on that winding. Yeah.
Can I get back into the?
Yes.
Yeah.
You guys are talking. Yeah.
Arduino, yeah.
I'll do it. Carry on.
1.8, yeah, that's the one I use.
1.8.19, I think. The last one from the old one. Yeah.
Same here.
And the thing is, all this new stuff feels like there's so much. They're putting stuff in there that I never use. Well, IntelliSense may be a different thing, I know. But for me, I don't want to be the one who does all the beta tests. So I'm waiting for. We talked about this. I think we talked about with Carther about libraries, and when you have good matured libraries. When the Raspberry Pi came out, the Raspberry 2040 came out. This was a mess. This was a total mess.
Yeah.
Nothing worked right, and I remember that I'd say I'd give it at least a year before I touch this thing.
Yeah.
Because I don't want to be the beta tester for a function that I need, and then to find out, oh, this doesn't work because. I remember back in the early days on ESP 8266, I was playing around with 166 megahertz CPUs then, and I found a bug that kept the I2C. It's simply lost a bit somewhere, and it wasn't the basic code. So I did the analyzer, but it took me 3 fucking days. I nearly went mad because you normally think, okay, this thing will work.
Kilohertz tester.
Yeah.
No, not me. I'm waiting for good mated libraries, good mated IDEs. Maybe the 2.4 is a thing for you.
Marked, right?
But I see, sorry, I didn't read this. You don't like the IDE to
One's there, one's there.
So that would take a lot to move me over that. For right now, no really need. So I stopped my rant now. So
How old is
Gordon, I see the video on net schematics. Yeah, I can do that.
Right.
Yeah.
Is there enough to do a video about this? You know how I think. You know my schematics, and some people really hate these. I just throw one, and Richard said, "Oh, this looks messy." But I can't. When you look at something old like a C64 schematic, I get dizzy only looking at this stuff.
So what you do is, you can do it with a normal...
It was nuts. I have a clear line of sight where I want to go, what you do.
And you divide it by 0.6.
Keep this in mind. Next one. Okay.
So it doesn't
Back to the
work
guys.
on small inductors or transformers.
So guys, we were just trying this while Detlef was chatting there. So with a small inductor, I can actually measure the inductance in millihenries using my ESR meter. So you take the resistance reading and you divide it by 0.628, and that gives you the millihenries.
Yeah, but it doesn't work on...
But on the big transformer it doesn't work. So I would usually use this and say get the resistance, and then you just a simple formula to convert that into the inductance.
Yeah.
But when we try it on a transformer,
it's not... It doesn't have enough inductance to actually...
it has too much, so it goes over range. So we can we can set this to 0. It'll 0 by itself probably now. Yeah, close to go again. Right, so that's 0 the meter. And then when we measure the winding, this is actually going over 100 ohms.
Gordon, you're welcome.
So it's over limit. So
yeah,
so I don't know. I've got a project to build an inductance tester from, would you believe, PCBWay?
Yeah, they have a lot of cool stuff.
So yeah, we can try that, but I'm not sure what you would gain by measuring the inductance of a transformer.
You can see how much power it can transfer.
Well, actually, I took this transformer. I want to make a video. I will do it shortly. So this came out of an AV amplifier.
Yeah, it looks beefy.
Yeah, it has mains in, and I actually measured this was plus and minus 35. And these were, I think there was a 5 volt and 9 volt and a plus and minus 15. Yeah.
I should get glasses back on.
And the question was, and maybe some of you guys would know about this, is how do you work out what the current is rated of a transformer? You can measure the voltages.
Thickness of the wire.
Thickness of the wire is a good one. So I did a bit of reading around, and apparently a transformer is rated normally. So there's, if you put a load onto the secondary, and the voltage will lag, it will drop, it'll come down.
Yeah.
And if it drops by 10%, at that point that's the rated.
Yeah, okay. So they don't do destructive test, obviously.
Yeah. So you load the transformer until the voltage, I think it slumps, I think was the word they used, by 10%, and at that point that's the actual rated.
Oh, I see a question there. Ian, do you use Kodi with Platform I/O? Or
He does. He says it so.
No. Kodi is an AI assistant for coding in Platform
Come
I/O.
on, you guys, don't be that lazy. Lazy is normally my tool.
No, but it's really good. it actually knows that your entire code base at the same time, so it can actually find faults really easily.
I think this is too early.
I tried it out. It works. It actually found a bug in one of the 3D printers firmwares I was looking for a while. So
the embedded hobbyist. IDE and libraries. Yeah, absolutely. This is what I meant by library help. And yeah, I have one of my earliest videos that does the Welcome to Library Hell thing, and Maybe there's a thing for you.
Okay. I had to bring a piece of paper to answer a question. You finish that one? This is Ian Hewitt's question. What's the difference with measuring with a ring tester? So a ring tester is actually...
give me that. So. Okay, so...
It's to find shorted turns of the transformer.
Oh, sorry.
The overhead. Yeah, I can do the overhead.
Yeah. So you effectively have a primary on your transformer, and one or more secondaries. Yeah. And if you send like a pulse into here, so you take this end up to some supply voltage, and then drop it to 0, or do the other way. This is a plus voltage, and you put a switch here. Every time you switch the supply off,
It opens.
you get a back EMF.
Yeah, it drops. Okay.
It drops. What actually happens is you get an oscillating effect. So effectively you get something like this,
Yeah. Okay.
which goes to 0. If you put a shorted turn, so you say you've got a shorted turn in here, that shorted turn becomes another secondary with a short circuit on it.
And you get double ringing.
No, well, it dampens the ringing. So effectively, say you get the ringing like this, you just get like a...
So it doesn't double ring?
No, it just doesn't ring, it just goes
This
flat.
is the direction
Oh,
of the transformer.
it
Yeah.
cancels itself out.
Yeah,
Oh,
because
okay.
this is effectively a 0 ohm short. So
Yeah.
all the current, which is actually,
Bouncing in between.
yeah, you short it out.
Yeah.
So what a ring tester does, it just pulses the end of the transformer, and you count how many times it oscillates. Normally using a CMOS chip, and you actually light a sequence of LEDs. Every time it oscillates, you shift it 1. So the more LEDs that it lights, the better the transformer.
Okay. Yeah.
But the only way to tell, or so people said, if your transformer is good or bad, because the ringing will vary from one transformer to another.
True. Yeah.
The rate of the transformer, the quality of it, Q factor as they call it, will vary. Like that Q. So it was said that the only way you can actually determine if the transformer is good or bad is to get a good one, a known good one,
And measure it.
and see if it lights the same number of LEDs.
Yeah.
But what I found is, and I actually made a video about this, is if we took a transformer, yeah, like this, we put our ring tester on, it lit so many LEDs. If I then take a piece of wire and just wrap it tightly around the transformer and short the wire, so I'm putting a shorted turn on.
Yeah, pretty much. Yeah.
So effectively, I'm just wrapping a piece of wire around here and shorting it. If a lot of the LEDs go out when I put a shorted turn on, the transformer was good.
Yeah.
If when I put a short on, nothing much changes, there's already a shorted turn on it.
Yeah, exactly, because it's
Because
it's behaving the same.
the fault is already dampening the oscillation. So when I wrap another piece of wire around it,
Yeah.
and put a short, it doesn't make any much difference. Anyway, that's the answer to that.
Yeah.
So a ring tester counts the number of these dampening oscillations. It simply uses an op amp. So this is like a fixed level, yeah, op amp coming in. This is like your ringing, and then this goes to a shift register. So the shift register has a clock. Yeah, this clocks it. Your data is just held high with a pole up. So every time it clocks one more time into the shift register.
Yeah.
And the other end of the shift register is your LEDs.
Yeah. Not a bad idea.
That's how it works. I built one.
Yeah.
PCB way.
I saw the video.
So Ian, if you have a look, you'll actually find the video. If you can't, if you get the email electroniccanary@outlook.com, I'll point you to the video.
It's getting hard to find the stuff on
Oh, yeah.
Richard's channel.
Yeah.
Because he has so much videos.
Yeah.
He's a machine when doing videos.
Yeah, I know. I can't.
Incredible.
I can't
Yeah.
keep up with Richard.
Yeah. So that's how I did it.
Okay, 5-minute warning, I think.
Yeah.
Okay, 7.
Want to show the guys the current state of Mr. Blink?
Yeah.
Current state of Mr. Bleep. Is it still alive? Yeah. I need to implement Mr. Bleep on my crappy measuring thing.
We need a
You can use it.
power bank.
Yeah, okay.
Do you want to get your red camera on?
I can do. Let's do the handheld. I think this is.
Just in case if it blows up.
No, it doesn't. Come
No.
on.
We missed one today already. we didn't think that would blow up either.
That's true. That's true. So this is Mr. Bleep.
No,
Okay.
This is the SMD version from Richard's video from the start of this week. And yeah, we got them populated. And this is the first time on video that people hear the beeper.
Making everything
Beep beep.
Do you want a diode?
Yep, please.
Shock kid normal.
Because a short is fine.
What you see here is the program adapter over there. Yeah, this is a program over there.
Yeah.
And the wires you see here are directly soldered onto the SMD pads where the SMD CPU will go.
Yeah.
And believe it or not, I don't have SMD CPUs for that.
Yeah.
So we want
Just ordered them and they probably arrive sometime in the future.
So what you've done is then you've Frankenstein this. You've connected.
So pretty much.
You've soldered and then put a bit of hot snot, these wires, back to this. So this is emulated. This is an ICE in circuit emulator. It's emulating
in a way it is, yeah.
Yeah, this is exactly what it is.
it's circuit emulation. Right. So if you clip
This and piping, you can skip pretty much if you have the SND component.
so
You still need a power supply to
No, you don't.
no, Luke.
for Mr. Is
Yeah.
it?
These aren't boobs. These are
Oh.
CR 2023.
These are not boobs.
Not boobs.
No nipples, Luke.
You sure? I would put some nipples on.
And let's face it, boobs without nipples are pointless.
Yeah.
Oh man. Let's wait for this one.
Literally and figuratively. Okay, yeah. Sure, fine.
Boobs without nipples are pointless.
Figuratively.
You can show the people.
Yeah.
Why didn't you design nipples on?
Yeah, I need to update the footprint there.
Listen. So
Short bleep.
short bleep, and then we take a Schottky diode. Should be a different frequency.
Do you have a Schottky diode?
That's one. You have it in your hand.
Sorry. I thought it was transistor.
No, there's a Schottky
With a
diode.
broken leg.
No, other way around.
By the way,
Yeah, I'm trying. This stupid alligator clip doesn't want to let go.
So we got blue for a Schottky diode, green for a normal diode, and red for a short.
Yep.
Yep.
And if you want to have different colors, I can implement this too.
Yeah. No, the colors are fine.
Can you guys hear that?
Kind of what?
I don't think I can hear it.
Embedded hobbyist. I once sat on a transformer and boy did it test my ring. I think that should be quote of the night.
Yeah, it is.
Inductive. Yeah. Okay.
Okay, so here are the other bits. These are the battery holders.
Yeah. SMD style. Yeah. No, there's a
Through hole, yeah, they're through hole.
So they're through all. They go to the back of there.
Yeah.
Yeah, I like these more than the SMD ones.
Yeah.
So Carlos, can you
Yeah. Okay.
This is a new
3D
one.
print a holder for this?
Yeah. Do they
Uh,
have a spare board for me?
we
Yeah,
have
sure.
5
Well,
spare boards for you.
Yeah.
And we have the battery.
I just need one, so I can do the video on how I design it.
Yeah, but I think you'll need some battery holders so you know the
Yeah.
depth of it.
Exactly. So the battery holders and the switch, are pretty much
Yeah.
what I need.
Yeah, there you go.
Because the height of these components are pretty much.
Yeah.
I do need to know exactly where this lines up.
You on the electronics channel thing on EasyDA, so you can have a look at these.
Now test Zenas. I actually Paul too, so I actually use a LED backlight tester to do Zenas because it's the only thing that gives me high enough voltage.
Yeah.
Basically.
We were running at 6 volts here, but with the 2032.
Yeah.
So this is maybe not enough to do something above 5.1 Zenas.
Yeah. No. it won't.
Well,
unless we then start adding like a DC to DC converter.
yeah.
to it.
There was
No.
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 It is
You know,
possible,
yeah.
but this project is already matured and it works like
Yeah.
it should.
This is a project that is finished.
Yeah.
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 No, it's finished from us, but it's not finished from Finersi because I know as a fact that they're working on incorporating Mr. Bleep into one of their new test meters.
Yeah. What do you think about the little beeper? This was a thing.
Quiet, but works.
Yeah.
This
20
one, right? That's the beeper.
I have 22 ohms in series.
Take the resistor out.
We maybe can make it a bit louder.
Yeah, without the resistor.
Take the resistor out.
Where's the resistor?
Where's the resistor?
Under the hot snot.
Well, we've got one.
okay.
We have 1 minute left.
Yeah, no,
Take the
no,
resistor.
That won't work.
no, it's
No.
too short.
Okay, guys. So I think we I have to call that a day, I'm
Yeah.
afraid.
Good night.
Yeah.
Nice.
Did you enjoy it, guys?
Something different.
Yeah, we didn't blow anything up this time.
We did.
But we did.
We did.
It was just so long ago,
yeah.
you can't remember.
Sorry.
We blew it up, but unfortunately off
No.
camera.
Not on camera.
Our good friend,
Oh.
the 80 Tiny over here, is dead.
Yeah.
It's a sad day for microcontrollers
Okay.
and stuff.
Dual thief circuit, lipo down there.
That could work.
Yeah,
Dual
thank you.
thief generates a very high voltage there. Yeah.
Okay, we can play with that.
Yeah.
Yeah.
That's not a bad idea, actually.
Yeah, yeah. See you in 2 weeks, PM Chris. Thank you, Digital Toys. Hope you all enjoy this.
Have a good night, everybody, and yeah, see you at least in
Cheers.
2 weeks.
See, salute.